Are you confused by the term regression? Are you getting nightmares about betas and their p-values? If your answer is yes, then you are at the right place, because today we are going to go through very basics of regression. This video is intended for the absolute beginners who are just starting to understand what regressions are. I will not go into the technicalities. In my channel, I usually do not go into the technicalities. I'm not saying that they are not important, but in most cases we need regressions just to do some basic tasks, and we do not really need to understand the mathematics and statistics, all those technical terms behind the estimations of betas and regression. So today we will just go through a very simple example to understand what regressions are and how you can use them in your research project. So let's say I want to buy an apartment in Berlin. I go to a real estate agent and I ask her, I want to buy an apartment in Berlin, how much does it cost? And she'll be shocked. What kind of question is that? She'll say, okay, I need some more information, I need some specifications. And I'm like, why does it matter? And she will say, well, if you want an apartment in Berlin, I need to know how many bedrooms do you want, right? If you want an apartment with a balcony or not, on which floor do you want your apartment to be, ground floor, first floor, or second floor, and do you want it to be closer to the city center or not, right? All these factors affect the price of the apartment that you are looking for. So basically what she's telling me is that if I want one additional bedroom, the price of the apartment will be 5% higher. So if I have two options of very similar apartments, but one of them has one additional bedroom, then the price would be 5% higher. If there is an apartment with a balcony as compared to the apartment with no balcony, I have to pay 2% higher price. If the apartment is at the ground floor, I have to pay 6% higher price as compared to the apartment which is at the first floor. And if I want an apartment closer to the city center, then I have to pay 10% higher price. So what this means is that the house price is a function of how many rooms it has, on which floor it is, whether it has balcony or not, and whether it is close to the city center. And my real estate agent just told me that these are the numbers by which the prices will increase if I increase, for example, if I increase number of bedrooms by 1 and I do not change anything else, then the price of my household, not household, but price of my house will increase by 5%. Have you noticed what I just said? I said if I do not change anything else, meaning floor, balcony, and city, I'm not changing. This is what we call ceteris paribus. In economics and statistics, you might have heard this term so many times. Ceteris paribus, everything else unchanged. We are not changing anything. And that's what it means. So we are comparing two apartments on the same floor, both have balcony and both are in the city center. We are just changing a room and isolating everything else. We want to see what is the impact of increasing number of bedrooms on the price of the house. Here we have house, but we are talking about apartment, right? So this is what we mean. So these percentages in red, these are actually your betas. So if I want to write this in terms of an equation, it will look something like this. So beta 1 here represents the 5% that you have up here. Beta 2 is the 6% right here. Beta 3 is the 2%. Beta 4 is the 10%. These are the estimated approximate coefficients, which is the increment to the price if we change something in these variables. So meaning that the price of an apartment is dependent on these four variables, meaning that these variables are independent and the value the price of an apartment is a dependent variable. And this is what we see in regressions, dependent variable and independent variable. So the price of the house is dependent on these. This is why we are calling it a dependent variable, and these are the independent factors, so that when we keep everything else the same, we can vary one of these factors to see what kind of impact it has on the price. This part right here is the intercept, which means that, let's say, if there are no bedrooms, if you put 0 here, if it is on the ground floor, you put 0 here, if there is no balcony, you put 0 here, and if it is not near the city center, if you put 0 here, then all of these things will be 0, and anything that is left here would be beta naught, which is usually we call it intercept. So that would be kind of a base price of any apartment which has none of these features, right? So of course, in regression, like in order to predict a price of something, in this case of an apartment, we need to look at several factors, maybe hundreds of them. We only have 4 of them. So some of the variation in the prices is captured by city, some of the variation is captured by this, 4 variables. Everything that is left out of the equation, which is not included here, it goes inside this epsilon right here. This is the residual or error term, which captures everything that is not captured by these 4 variables. Okay, so I hope that it is clear. Now, once we have this beta, the next thing that you might see in the regression analysis is the p-value. We have t statistics, we have standard errors. We are not going into those details. We are keeping it very simple today. So we have something called statistical significance, and we say that, okay, the p-value is less than 0.05. This is what we usually say. This is the rule of thumb, that if p-value of any coefficient is less than 0.05 or 5%, we say that this coefficient is significant, statistically significant. So we are going to go through a very simple example just to understand what this p-value means, right? So the rule of thumb is something like this. It might look dry, but I'll try to explain it as easily as I can. So statistical significance means, the rule of thumb is, if p-value is less than 0.05, the beta coefficient is statistically significant. So this is the rule of thumb that you have to remember. This can vary in different fields. For example, in medical sciences, this p-value is much smaller, because chances of error has to be minimal, because it's a matter of life and death. In social sciences, we can have, it's rare, but we can have 0.01 as well here. So rule of thumb could be 0.01. So if there is less than 10% chance of committing an error, sometimes in social sciences it can be acceptable. So let me give you an example of a bag which is closed and it has 100 balls inside it. I cannot see inside, I cannot see the color of the balls, and I have to put my hand inside and pick one ball from that bag, right? So I do not know what is inside, but in reality we have 95 blue balls and we have 5 red balls in that bag. I do not know that. I just put my hand inside and I have to randomly pick one. I put my hand inside and I take one ball out of the bag, and that is a red ball. And based on that red ball, I might wrongly interpret that all the balls inside this bag are red. In reality, we know that 95 of them are blue, but since I got this red ball, I assume that all of them are red. What happened here was the red ball was selected by chance. The likelihood of selecting blue is much higher because there are 95 blue balls, but by chance I picked the red ball. That's what we want to avoid when we are estimating betas. Betas are also something like you are picking a ball from a bag full of 100 balls. So let's say that you do an experiment where you take sample of houses from a neighborhood and you do this experiment 100 times. You take sample of the houses 100 times and you estimate betas. So what we want to ensure is that the likelihood of estimating a wrong value of beta is minimized. So in like connecting it with the analogy of balls, I want to make sure that the chances of estimating the wrong value of beta 1 is less than 5%. So in other words, what it means is that there is a 5% or less likelihood that this beta is incorrect, right? In very layman's terms, I'm not using type 1 type 2 errors language. I'm just giving you a very simple example of what does this mean, right? So it means that there is a 5% or less likelihood that this beta is incorrect, or this beta was estimated by chance, in the terminology of the ball experiment that I was just talking about. So if you see this p-value equal to 0.05, it means that there is 5% likelihood that this estimate might be incorrect or far away from the true value. These betas, by the way, are estimated values. These are not true betas. True beta is the value for the entire population. Most of the times we are dealing with sample data, so we are estimating those betas. So these are estimated values, and we want these values to be as close to the true value as possible, right? So whenever you see p-value of less than 5%, it means that your coefficient is statistically significant, meaning that there is only 5% chance, that 5% probability that the estimated value of beta coefficient is by chance. It means that the estimated coefficient is wrong. That is, there is only 5% likelihood. So this is what it means, and I hope that it was clear. Thank you very much for watching.